So this is the third part where we will talk about the white water, particularly how to create it and generate it, and we'll go through the render setup. Okay, so this is the render as you can see it for now, done in Karma. Okay, close. So we finished the part about the rigid body, and we finished the part about creating the surface, the Flipfluid, and now we are in the part of white water. So we start with the first node that we will import and prepare the setup for the white water. So we object merge the sculpted fluid, this one, after it was exported from the simulation, and it should have 2 VDB, surface and velocity and particles. This is the 2 measure thing. Then we have to create the node of white water sourcing, where we define the depth, how much deep we go down to look up for the particle to be generated, and the angle for the curvature, so how much it's curved so it can emit particle, and the speed at which the range that will particle be generated from, not below, not above, and the vorticity. And if we have extra volume, we can hook it up here if we want a specific source, like we create a circle here, or noise pattern, and we create water from it, so it will generate white water. Also, if you want to create a volume from this particle, and this is the visualization. Okay, so same thing here. I added a null, and in the geometry render output I added this null here. Then I cache the white import or the white source, and I read it through another read file. So this is one of the frames. So as you can see here, according to the color, so curvatures is the red one, acceleration, which is the most particle, are in green, and vorticity down here below for extra detail. Okay, so after that one we add an output, and we go to the white water simulation. And in the white water we use the same setup for the static object that we imported from the RBD, including the fragments of the glass and the car, and we put the proxy of the VDB. Here we need white water solver, which is we define where is the emission from it, and the amount, and the limit, and the forces. These are all the default one, and we want to add foam, clump, and erosion. Even it will be chaotic, but it's not, it's add-on. And this is where it will be saved in the simulation file. After that we go to the white water import. Here we get the file dob in and out import that I added a null, and null 12 I added here, and I cache it and bring it back to this file. And in this file I have 2 out nodes. I have particle and I have volume, because I want to render both. So the particle, you can play with the scale, and if you are using USD or Solaris, you will use width instead of the B scale. So let's choose a frame. So in this frame we have 13,694,000 particles, as you can see, chaotic. Let's choose another one. have 15 million, not, I mean, for this machine and its RAM and the time I have, it's fairly enough. On the other side, we set up the density. It will be generated from the shelf tool with the density by the age and by the depth, so it will go deep. The very fantastic volume rasterized attribute, and we are doing the density here. Then we convert it to a VDB. The density is being converted, okay, and we do the gradient from scalar to vector according to the gradient. I'm going to put it here. Let's have a look. One of the frames. So this is how it will look, and the gradient will help with the reflection and specularity of the white water, so it will be more natural. Another frame, cool. So after that, I keep the render flag on the white water volume, and here I object merge the particle itself, and I make the attribute for the B scale 0.01, so smaller. Okay, so what I am rendering out, let's just cancel it. What I'm rendering out is the scene, the geometry, the surface, the white water, and the object. And I had one camera here that I animated by hand. Go through the scene, slowly revealing the animation. Straightforward animation. Okay, let's give it a second. I'll show you the animation. This is the camera animation. Not that much, but resemble a handling camera. Lights. I have a couple of lights. I have environment light that I added a HDRI for it, 4K. Distance lights from the same sun angle. So it will cover the whole window. And inside, let's choose one of these lights, rig, Ctrl G. This is the lights here. I add them here one by one. As you can see, every three lights together, I connect them to a null so I can control them. In the render, I went with Karma, because mantra will take ages, and I went with minimum, which one I render this one. I went with minimum pixel sample, so it will render a little bit faster, and I went down with the limit, but what I did, I add the denoiser of the NVIDIA. So okay, it will not be sharp, but enough for visualization. Also, I'm rendering out an OpenGL. The OpenGL just to demonstrate the simulation like a flipbook, but in a better resolution and better anti-aliasing and better image quality. And I hooked them up on a merge that I will render as node by node. And the texture for the white water, straightforward principal shader with high metallic reflectivity and transparency. Same thing here also. This is the render, the object, the out, and what else remaining? I think that's it. So when the render output is completed, I will submit it in a separated video with the scene file, hopefully it's not large size. Thank you very much for your support. Thank you.